In question 15, we want to find the indefinite integral of x squared over x cubed minus 4 quantity squared dx. When we look at this expression, it's certainly not a basic antiderivative. So what we want to do is try to do a u substitution here to help us out. One of the common techniques that we saw in the past is to try to let u be an expression that's under a power. So if I look in the denominator, I see that it's x to the third minus 4 is being raised to the second power. So let's try to let u be x cubed minus 4. If we do that, I can differentiate this expression to get the du is equal to 3x squared dx, and that's very nearly what's remaining within the integrand. The only thing that we don't have that we would currently need is a 3x squared dx. Well, we have the x squared dx, we're just missing the factor of 3. We can multiply on the inside of the integral by 3 by multiplying by the reciprocal, or dividing by 3 on the outside by putting a 1 over 3. If we do this, we can make the substitution. It will become 1/3 the integral of the 3x squared dx will get replaced for our du, and then what we're going to have is our denominator will look like u to the second power. And now this is going to turn into a basic antiderivative in the variable u. To do this, we would first want to rewrite this. This is going to be the integral of u to the negative second power du. We can find this antiderivative by using the general power rule. I add 1 to the power. Negative 2 plus 1 is negative 1. Divide by the new power, and then have our plus c. This is equal to a negative 1 over 3u to the first plus c. So just go ahead and kind of simplify that. At the end of the day, remember we started with an antiderivative in the variable x, so we need to end with an antiderivative in the variable x. Go back to your substitution equation, and wherever you see u, we're going to replace it with x cubed minus 4. So there's our final answer. The indefinite integral is negative 1 over 3 times x cubed minus 4 plus c.